Assalamu alaikum. Good afternoon, everyone. I know everyone is extremely tired after 2 long days, but we're saving the best for last. So this is the biggest panel we've got on the Congress with 8 very valuable panelists, which I'm very grateful to have here today. At the UAE, as a country, we are very passionate about education, and the agenda of the country has been forming to increase STEM education. So today we want to focus on education in space, basically. How are we to develop the workforce, young people like you? And how will the actual program add value and inspire people to study STEM? And how do we find the next leaders? So very exciting panel. I'm going to take a moment and ask every panelist to introduce themselves and what got them into space and education in particular. So on my left, I've got Mohammed Al-Harmi.
Good afternoon, everyone. Thank you, Sheikha. As Sheikha mentioned, I know it's the last panel, and probably everyone is tired, so bear with us. It's going to be very interesting. My name is Mohammed Al-Harmi. I'm the Director of Corporate Development in Mohammed bin Rashid Space Center. I started my career in space 12 years ago, where I lived in South Korea for around 8 years to do the know-how technology transfer, and I was involved in building and manufacturing 3 satellites and different projects in Mohammed bin Rashid Space Center. And before we talk about education, I'm going to tell you, when we started, we were students. Alhamdulillah, we achieved what you can see now in the UAE.
Dr. Bjorn.
My name is Bjorn Scherve. I'm the Chancellor of the American University of Sharjah here in the UAE, and I've been in that role for almost 3 years now. My personal specialty is physical oceanography, so I come at this from a very different point of view. But as a physical oceanographer, I have greatly enjoyed the use of satellite imagery of the oceans and the Earth. So I see space science from my area of specialty at the applications that it can provide to understand the Earth better. In my role as Chancellor, of course, I'm leading an institution which has specialty in engineering and the sciences, among other fields, and my responsibility is to make sure that we educate well the young people who attend the institution, and we help the country by providing the workforce, which is targeted for good applications.
Okay. Dr. Scott.
Well, good afternoon, everyone. My name is Scott Madry. I'm from the United States. I'm a lifelong academic. I hold a faculty position at the University of North Carolina. I taught at the International Space University for 24 years at many of their programs, and I'm very proud to say I have quite a few of my former students here in this room, which is very pleasing to me as a teacher. And I'm the executive director of the Global Space Institute. My interest in speaking here today is, as an academic, I have turned my former students loose on the cold, cruel world every year and have seen some succeed and some fail. And so I became very interested in workforce development activities and the transition between being a successful student and being a successful participant in the space community. And so I'm a member of the International Astronaut Federation Workforce Development and Young Professional Committee. And that's an area where we work specifically on developing the skills for workforce and for young professionals, and that's some of what I'd like to talk about today.
Excellent. Thank you. Dr. Gabriel.
Good afternoon. My name is Kamiel Gabriel. I come from Canada. I am one of those students that he taught me, so I can call him Daddy out of respect. I was graduate of the International Space University in 1990 from York University in Canada. I started my career in space science by accident. I just found that after I got my PhD, The topic of my PhD was exactly what NASA was looking for the design of the thermal transport system for the space station. So I was invited by NASA Johnson Space Center to be part of the team that designed the thermal management system and operated. And for 14 years, I performed extensive research in microgravity, looking at the performance of the system in the weightlessness of space. During that time, I discovered that I really, every time I go to NASA for a meeting, the questions cover more than just technical aspects. The questions start to be about ethics, about policy, about procedure, about business plan. So I was tempted to go to the International Space University, and I was lucky enough. In fact, they called us the Lucky 13 in Canada, that we were chosen in 1990 to attend the International Space University. And since then, I took it on myself to be space educators. So I started a Space Science Education Network in Canada with funding from the Canadian Space Agency. And I continue to be interested to do so, and hopefully in the UAE.
Thank you. Anu? Professor Anu?
Good afternoon, everyone. Shaker, you asked two questions. So briefly, in answer to the first one, what brought me into the sector? What inspired me? I'm a child of Apollo, but I'm also a child of Viking. My earliest memories include seeing the geologist Jack Schmitt walking on the moon in December 1972. Now, I was 4 years old, so there's quite a hazy memory. But by 1976, when Vikings 1 and 2 landed, that was it. I was hooked for life. So for me, it was the inspiration of exploration, which has continued as I've been more and more involved in the satellites that look back on Earth, so the exploitation of space data. But why I feel so strongly about space education and why we have the National Space Academy program, you know, so many people, all of us here, we believe in the power of space to inspire, but inspiration on its own is not enough. That lights the fire. We need to keep the fire going. We need focused skills development programs working at school and university level, bringing industry together so that students can see viable pathways into the sector. So for the UK National Space Academy, we work across the UK. We work with ESA. We work in China. We're now working with the UAE Space Agency, which I'll be talking about hopefully later. But again, in conclusion, the best reward you can get, following on from my two colleagues, is when you see the inspiration and the focus of the students in the audience. And I also have some new students who I can see in the audience here. They include our UAE space ambassadors who have been helping. Ladies, would you mind just waving your hands? And also two other undergraduate students who are part of our masterclasses yesterday. When you see that this is the next generation and you see the focus and the talent they have, that draws you in and keeps you working in this sector.
Professor Morton?
So I was inspired a bit like Anu with Apollo, but in the 1970s when I started my science career, you couldn't be an astronaut, which is what I wanted to be. So I became the next best thing, which is a rocket scientist. And I've been a rocket scientist since about 1979 when I joined the University of Leicester as a space researcher. But my interest in broader education really arose in the mid-90s when we had a cataclysmic crash in student numbers in all kinds of science subjects in the UK. And in a university, if you don't have students, you're in real trouble. So the motivation for getting involved in wider education was slightly selfish because I wanted to get more people doing science at school. And space seemed to us to be an obvious way of inspiring students to do science subjects. So we always presented basic science in the context of space, and that proved to be a real winner and led to us to build the National Space Centre in Leicester, where Anu now works, as a vehicle for trying to stimulate that excitement in science. And we have improved things, but there's still a long way to go.
Dr. Todd?
So good afternoon, everybody. Pleasure to be with you. Thank you for hanging in there till the late afternoon. I'm president, similar story to Bjorn's, I guess. I am president of Khalifa University here in Abu Dhabi, which is an engineering and science-based university. And my background is actually as a mechanical engineer. I spent several years at Duke, actually nearly 20 to be exact. So hopefully Scott, my colleague from UNC, won't give me too hard a time about that. I am a Dookie. But I think, you know, how I came to this is from a couple of different angles. As I said, I'm a mechanical engineer. In my academic career, I've chaired departments that effectively had our university's aerospace programs in them. But I would say that initially my pull to aerospace was through my own scholarship. I'm a computational mechanics person, and over the years I've had sponsored research from a couple of different NASA labs. I've worked in the Department of Energy labs in the United States and had some tie-in there. And there always, at least during my lifetime, space has offered the opportunity to really push the envelope of a lot of things that we can do on Earth. And of course, for researchers, which I think is part of student motivation for increasingly in entering any technical field, in addition to capturing their imagination, the opportunity to really explore the unknown in a very visible way is something that I think space has always offered. But I would also say that my other attraction has been sort of from an engineering education example, or from an engineering education perspective, I should say. I'm a child of Apollo, and unfortunately I'm a little bit older than you are, so I remember Neil Armstrong very well, walking on the moon, and so I think many of us of this generation sort of have almost a visceral a sense of motivation that comes from that. But one of the things for me from an engineering education standpoint is that, the way in which we want our students to experience any technical material, whether it's in aerospace or in any other area, is much more intentionally hands-on now than it was certainly when I was a student. And so I think some of the opportunities that space provides us to provide students now, even from an economic standpoint, with a meaningful opportunity to do real projects in this sector. When I grew up, and now I'm dating myself again, most space-related projects that an engineer could access were almost hopelessly high-ended. It was very difficult to think, even if you wanted to deliver this experience to your students and enable them to analyze a project, build it, test it, take it through to some stage of completion. That was quite difficult to do in some respects, whether you were talking about satellites or rockets or whatever it might be. This is no longer the case today. And I think using that power intelligently to attract more students to the field is a tremendously positive opportunity for engineering education, and I think an interesting topic that's likely to come up today.
Thank you. Astro Yamazaki.
Thank you, Shukran. My background is actually an aerospace engineer, and inspired by lots of science fiction movies like Star Wars and cartoons. And I started my career as an engineer at JAXA and then joined in an astronaut corps. And after our mission on board the ISS, I have been serving to the Cabinet Office as a committee of the National Space Policy, and also for the space education as an advisor of the Young Astronaut Club. And actually, I am currently a student as well, a PhD candidate at the University of Tokyo, so lifelong education, for example. And I think I will talk later more, but two aspects are very important in the education and the human capacity building. The continuous educational opportunity, and also JAXA's Vice President Yamazaki mentioned yesterday about the friendly competition. I think those two are very important.
Okay. Thank you. Because of the number of panelists we've got today, so we're going to keep it very light. I'm going to ask each of them 2 questions, and we'll take it from there, okay? Ready, everyone? So we're going to start off with Mohammed Al-Harmi. Mohammed, talk to us about the steps that you've been taking, establishing the education in the space sector in Dubai or in the UAE.
Okay. Of course, we have different steps that we took when we started our careers. I would start with something that might be a bit inspirational for the students. My background was never a satellite engineer or a space science engineer. My passion was football when I was younger. I never thought that I'll ever be somewhere close to working on satellites. So I did my studies on engineering, software engineering, and then I resumed my higher degrees in aerospace engineering. So I learned that through the process of starting Mohammed bin Rashid Space Center, which was EST before, until this day. Of course, a lot of the inspirational things that we do for the students, we give inspirational speeches in different conferences. We usually go and try to outreach different students and make sure that what we're doing is not impossible. It's actually something that just needs a bit of motivation, and you make sure you set your goals and you achieve your action plans. All these things are just slight things that you have to do with time. Of course, we have our nano-satellite outreach program. That's another thing that we do, and we did with the American University in Sharjah, where we had different students from the university themselves involved in their final year project of working on and developing the nano-satellite, which was their final year project. So that was another way of reaching out for the students. Of course, we have different generations. Student workshops is another thing that we do, where we gather students and we explain to them how we work and what we do at work and how we achieved our goals. And we have the Space Olympics. I'm just throwing out examples of outreaching to students. So the Space Olympics is an event that we do yearly, where for a week, where we get students, whether they're in high school, middle school, or university students, to Mohammed bin Rashid Space Center, basically go through different processes that we go through. For example, how to operate a satellite, how to image process, how do you go through that full process of engineering, giving them actual PC boards for them to do some soldering. So that's some of the examples that we have. Of course, teacher ambassador program. That's when we're done with students, we try, education is something very important for us. So the teachers themselves, they have to understand what level of technical details or requirements or specifications that they should understand so they can transfer that knowledge to the students in the country. So, and for the youngsters, of course, I won't forget the young generation. We've done different magazine called the Red Planet. That magazine is usually we're aiming the young generation between 6 to 12 years old, because as you know, the future are the students. We've reached a long way, and we've done a lot of things, alhamdulillah, in the UAE. And what we expect from the future generation is to embark that educational level. Education is something that, unfortunately, these days are all theoretical. And you have to memorize things, and you have to study things, memorize formulas. I feel, in my point of view, it should be easier. It should be the adaptation of the students to what they really feel like doing is something very interesting. We should get them out of that comfort zone, I will call it, and get them out of that bubble and let them do what they want. Let them join us when they're young, and let them learn from what we're doing in the space sector. Just the last point is we have, of course, the remote sensing application workshop or program. Basically, that is a competition that we do yearly basis worldwide, where we have different entities in the world or different universities in the world preparing a certain application that will serve the government. And alhamdulillah, we've been doing it for the past 2 years, and we're getting students locally and internationally. So this is just some examples of how we reach the students.
Very comprehensive, Mohammed.
And
Thank
thank you.
you. That's wonderful. So, Dr. Bjorn, following up on what Mohammed was talking about with the nanosat and knife one, I assume, is the one that you were talking about. Why is space such an effective tool for encouraging national development of STEM education, do you think?
From my perspective, there are 4 ways of moving forward. You need leadership, you need ideas, you need funding, and you need talent. So those are the 3. On the first one, I'd like to congratulate UAE. I'd like to congratulate the UAE Space Agency and the Mohammed bin Rashid Space Center for providing the leadership in the country to focus attention, to define a program and move that forward. With that comes ideas that are homegrown and ideas that are generated in partnership with other international space groups around the world, or space application groups, as it might be. In terms of funding, at the American University of Sharjah, we are cheering the fact that we will be able to give scholarships to a number of students from funding that's made available either in the form of employment or internship, or actually funding for students who are studying. On the other hand, so that's a positive part. On the other hand, if I look overall at the funding in research and development in UAE, it is probably very low compared to other developed countries. The data that I have from the World Bank indicates that funding is only 0.47% of GDP for research and development. Hopefully that will in time grow, and that will increase the capability in the country. Now, on the fourth point, which is the talent, well, that is a responsibility in part of the universities to grow that talent, to find the best students, to make sure that the best students are being mentored correctly, are being challenged in courses that are relevant and maybe difficult, and then help them beyond the university towards internships and towards employment in a particular field. Should you teach space science? Should you teach aeronautical engineering? Maybe you should, but maybe you shouldn't. That's probably not the most important decision. The most important decision is you take bright students and you give them the fundamentals in mathematics and in physics, and probably in language or communication in the form of English. I think those are the three most important areas. The higher level applications in aeronautical engineering, that's fine. You can do that as a senior or graduate student. But if you don't have your math, your physics, and your English right, you will not succeed. Sure. So at AUS, we emphasize the fundamentals in terms of the education. Well, we do have a minor in aeronautical engineering, and we do have an upcoming major in physics, and we are very proud of those. But we really want our students to be good in the fundamentals, and I'll say more later.
Thank you. So Anu, I'm going to ask you that question again. Why do you think space is effective in encouraging national development of STEM?
Well, it's a relatively different answer everywhere you go. But I am probably the only person in this room who has degrees in cultural anthropology. How many cultural anthropologists do we have here? It was a great way to get into the space community, accidentally. But I see almost everything we do in the space world, in space education, in the workforce development, even what we're doing here in this room today, as an exercise in cultural anthropology. And we all have our own cultures. We all have the culture that we are born into, but we also choose our cultures. We choose to be parts of subcultures of space law or engineering or science. And all of these are very different worlds. And I think every nation, every community, every region has to develop its own answers and its own perspective in how space can play a significant role in the development, not only educationally and in the workforce and the economy, but in the culture that we all live in. And so I think space plays a tremendously important role in inspiring students, in getting us to get students to take seriously taking science and technology, engineering, mathematics. But I think more than anything, what space does is it gives us a hope to hang our hats on in terms of the future of our world. Because if we can learn to live and work together on the space station, if we can learn to live and work together in this context here, then we can solve the problems that we face in this world.
Thank you. Astro Yamazaki, I'm going to ask you a question about how do you encourage national development of STEM in Japan?
Yes, as I mentioned before, the continuous educational opportunity and also the friendly manner of the competition, I think the challenges are important for those STEM career. And for the first part, in Japan, we have for the younger age, kindergarten through 9th grade, Young Astronaut Club, and for the high school level, cancer challenges. And the university level, the UNISEC, University Space Engineering Consortium. It's for the CubeSats level education. And for the internationally, we select a Try-0G program utilizing the ISS Kibo facility. And our Japanese astronauts try some zero-G experiments according to the proposal from various countries. And if, for example, last year, the JAXA proposed a call for the proposal, and more than 120 proposals came. And among them, 5 experiments were executed on board the ISS. And the good thing is the selection process is open, and so during the process, the students can learn how to, manage the experiments and how to make a presentation to make them understood themselves. So I just attended this afternoon, the Genes in Space program selection, and I think it is a very good example as well. So through the process, students can learn lots of things. I think that's important to be selected or not. It's not the first top priority. But how they can learn is the top priority, I guess. And for the young engineers, we are trying to have a frequent missions for example, for every 2 years, like a small satellite for the scientific or explorer. It cannot be a huge satellite, it takes longer. But for the smaller sites, we can maybe, every 2 years to launch. So for those kind of frequent opportunity it's helping the young engineers to gain the experiences. I think that's the key of the competitions. So through the international wise, we do Japan is holding an Asia Pacific Regional Space Agency Forum called APR-SAF every year. And last year, it was held in Manila, Philippines. And this year, it will be held in Bangalore, India. So through this network, not only the Asia-Pacific countries, but including, of course, UAE and some European countries as well. So I think this networking is helping as well for the friendly manner of competition.
Okay. So Professor Anu Ojha, for the same question, what do you think? Do you think space is effective? Of course, I know you do think space is effective.
Yeah, I would actually echo a lot of the comments that have just been made. This is certainly something we've seen in our students. And I think, one of the things that's so gratifying, if I go back 10 years when Khalifa University was set up, it was set up in response to a very forward-thinking policy document that was developed in Abu Dhabi, the 2030 vision, which people who live here will know well. And the interesting thing to me about this is that technologically, a lot of the sectors that were envisaged, and space and aeronautics were one of them, but there were several, right? Healthcare and logistics and many others. Many of these were very new industries in the UAE. You know, it was very forward-looking. The challenge was to figure out how to put them in such a way that they would attract bright young minds to them, but they didn't exist yet. And so I think one of the things, you know, and so we were given this job, right? You need to be an important driver in helping us do this. And we have found this model of international engagement on one hand, being able to aggressively provide our students the opportunity to travel other places, do real projects collaboratively with young students from other countries. We've probably done that more, actually, in aero and space, both, than we have in many other fields. But it's tremendously powerful. And, you know, of course, now with the leadership that Bjorn referred to earlier from the Space Agency, quickly developing more of a presence locally, that will continue to evolve this. But in terms of what motivates students on a very basic level, in addition, you know, inspiration somehow isn't enough. To know what goes into it, you know, to understand that, you know, the math and physics skills that were referred to earlier actually have a real context, and this is how they matter in the context of this technical field. I don't think that a professor pontificating about that in the front of the room is going to be all that effective to most students. And so this is where I think the type of engagements, the sort of collaborative competitions in many cases are really helpful, because it's not theoretical then at that point. And I think that the way, you know, you mentioned Genes in Space earlier, the CubeSat programs that a number of universities here in the country are pursuing and that the Space Agency is helping to lead are tremendously effective in this way. Not only to attract students to the field, but then also it's helpful developmentally in keeping them moving through the field, and keeping them motivated and keeping them grounded for the applications that they'll work on in the future.
Thank you. Professor Martin, how do we retain talent within the space sector? That's a big issue that we're facing today.
This is a real challenge, and I think that there are two problems. There's generating the talent in the first place, because if you look at how economies are developing in the modern world, and I don't just talk about space here, it's the whole of the science economy requires scientists, and we just don't have enough. It's a simple fact of life that the biggest thing we're going to have to do over the next few years is make sure that more of our young people coming through school stay in science streams, because they drop out at a range of ages as they are educated through their careers. So there are not enough to apply for university. When they come out of university, there are not enough to go out into our economic growth areas. So we really have to essentially treat it as a cradle-to-grave problem from the very earliest stages of school. At every stage of a student's life, we have to inspire them about science. We've heard a lot of good examples about how we inspire students into science using space. I think those will happen, but actually the big problem is that we don't have enough effort to put into it. Things like the Space School, I hope people have seen some of that working today. It's really wonderful, but it takes a lot of effort to get to a relatively small number of students. And somehow we have to get to our education ministries and tell them, you really have to change the way we teach science in schools for everybody, not just for a special few. Otherwise we will lose out. And there was a Women in Science session earlier today. At least in my country, not that many people go into physical sciences who are female. And therefore we're losing out on 50% of the population who could be scientists. And we have to do something about that as well. In terms of retaining people for space, that's something I think that the space industries need to work on themselves as well as academia. As an academic scientist, I work hard to try to devise courses that fit my students to go out into a range of industries, not just the space industry. But there isn't very strong dialogue between the needs of the industry that we try to feed and the academic courses that we deliver. And I think an important element of resolving that problem is for industrial partners to come in and tell us more about what they want. And space isn't just about engineering, it's more and more about physics, mathematics, and actually in surveys that we've been doing recently about computer science. and informatics. And in fact, the major growth area in the space industry will be in handling of data and creating products around that data handling. So the needs of the space industry are changing, and we need to react to that. So I think there's a lot to do, and it's partly practical solutions that we can do for ourselves, but also political solutions that we need support from the agencies and from the politicians who are interested in education.
Thank you. Professor Anu, so from your point of view, what can we do to retain the talent? So we're talking about there are so many challenges because we're losing the talent. What can we do to encourage more people to get into STEM education and retain it?
A quick story that's very personal before I give two examples from our masterclasses that we had today. I've just started the biggest journey of my life recently. I have a 2-year-old son. And suddenly, and I'm sure many people have been through this journey as parents, your entire focus changes. Everything becomes, you want to invest as much as you can in your children or in your next generation. And I feel that's what we need to do much more of as a sector to address many of the issues that my colleagues have talked about. We need to invest far more in terms of government support and from ministries, in terms of industries, and also in terms of some agencies. But that sounds very negative. I want to give some really good examples of how this has happened. We've seen, for instance, in the program that I am leading with the UAE Space Agency, support at the highest levels in government, including sustained funding for developing a national and a transnational space education and skills development program. That's why we're here. That's just starting. We have seen the support from industry in the time, in the form of the amount of time given and the amount of resource from not just large companies like we've seen Lockheed Martin support, we've seen Airbus industry support, but many smaller industries. We've seen the universities that are giving up their time to support this. So that's one area in which we can go into. But I think the most important way to retain the students once they're there is use those themes that are inspirational to build up, as one of our colleagues said earlier, their fundamental skills. So in today's sessions that were led by our student ambassadors, who I'm highlighting again, all of the high school students who came and the other university undergraduates were using Earth observation data in real time, looking at sea surface temperature, looking at satellite imagery to try to better their understanding of physics and chemistry. And once they got it, they were coming up with ideas that I couldn't come up with in terms of potential problems and potential solutions. Now, this was first order stuff, very simple. But, you know, we talk about the importance of innovation. Why should we be investing continually once people are in the sector? You know, I may think that I have lots of energy and enthusiasm as an educator, you know, but I am 3 decades older than the young people who are early in their careers, who are the real innovators. So we need to invest in them and make sure we don't lose the innovative spirit they have. We need to develop their fundamental skill sets, and then our space sector and our wider STEM industries may well reach their full potential.
Thank you. Professor Gabriel, how do we compare to other technical and engineering industries as a career path? Would you recommend people to work in space or not?
Well, I'll answer the question a little bit with picking up from where Anu finished, which is innovation. We need a little bit more innovation in space education and education in general. For far too long, the attraction to space education has been the wow factor of being related to space. But there have to be a substance beyond the wow factor, and innovation will require a more sustainable educational system. So I'm suggesting at 4 levels we can innovate the education. And the first level is the activity level. Space is a risky business, and the students spend most of their time in the classroom. The classroom is their workplace. So let's get into subjects where they can assume risk and fail and learn from their failures. Let's be more creative and innovative in approaching our teaching subjects, whereby they learn how to deal with risk and failure and get over it. So that's on the activity level. Let's not be afraid to open the door for them to make mistakes. On the course level, we have heard already the importance of the fundamentals of math and science and physics. But let me add that space, as we all know, is a multidisciplinary. So we have to continue to inject into our curriculum the multidisciplinary portion of the education, and not to focus on the silos that we have lived with since the education system developed after Second World War, the way we have it, at least in North America. The third level is the program level. Space is hands-on. It's an experiential learning, and I salute my colleague. I've been watching what he has been doing in the last 2 days, and this is just fabulous, what he has been doing. This is hands-on, this is experiential, and we need to bring that to the classroom and design our programs for the students to learn by doing. And finally, on the cultural level, when I was at the International Space University, our class was approximately 108, if I remember correctly. There were 37 nationalities in that class. And space forces you to learn how to deal with different cultures, adapt to different culture, respect different cultures, and being a person of a global citizenship rather than narrow-minded. And for me, the cultural level is very, very important. So I hope some of these aspects catch your question. If not, you can read my book about innovation.
I have it.
Okay.
I have a signed copy of the book, actually. Thank you. Professor Todd Laursen, I just got a question. Now, we've introduced the aerospace engineering in Khalifa University, and I know that you've graduated a batch of students from there. So how is it hard or easy for them to get a job in space, in non-traditional space nations? What are the challenges that the students are facing, the graduates are facing?
Well, so this may be a little bit UAE specific, maybe not. I'm not sure. But something Bjorn said earlier really kind of resonated with me. Part of our challenge, I mean, first of all, the country has really made a strong commitment to aerospace. So I would say in the numbers that we're producing students, they're getting very good opportunities. It hasn't been an issue. But it's also a natural thing when you study any discipline of science, engineering, or perhaps anything else in life that you develop alternative interests along the way. Maybe you become interested in a particular line of research or inquiry that takes you in a slightly different direction. And I guess my own feeling is that good universities shouldn't preclude that. And I think that we've already heard that people can come to fantastic applications and opportunities in space, not necessarily just from aerospace. So I'm quite in agreement with Bjorn on the fact that we don't have to be too rigid about precisely what a student studies, but probably want to think a little bit more about the skills that they've actually built, and there are multiple paths to do that. Now, what I will say, coming back to the UAE, is that the industrial sectors that we're dealing with don't always feel the same way about that. And so I'll use an example from engineering education. As I mentioned earlier, I'm a mechanical engineer. People don't really seem to understand that the difference between a typical undergraduate degree in mechanical engineering and an undergraduate degree in aerospace engineering might be 2 or 3 courses only in some universities. And yet folks do have an idea out there in the market that there's this vast difference, right? And so if they work in the space sector, and it's partly because the sector is still immature, right? But there's really almost a predestination that we really need to have aerospace. Well, that may be true, but that affects students for sure. And so I think one of the challenges we do have, and I've seen versions of this elsewhere as well, but I've seen it very strongly here. I think one of the challenges we do have is that students can sometimes make bad choices career-wise about what they're going to study based on real or perceived, and sometimes they're perceived impressions of what the market is and where they can go. And I think the better the sooner we get to a space where it's sort of understood, thinking about people in terms of their skill sets in terms, rather than strictly in terms of the degree that they happen to hold. I mean, it sounds like a very fundamental thing, but I think it's actually a real issue. And I say this as a university that offers aerospace degrees, bachelor's, master's, PhD. We very much believe in it, but we also think that there are other paths to really make important contributions in this sector. Data science was mentioned earlier, and that's going to be huge in the future.
Thank you. Dr. Bjorn, would you agree that there are about the same challenges that Dr. Todd mentioned?
Yes, I agree. I agree very much on this one. And I just some further reflections. We heard that there were some children of Apollo and Viking here. When I was a child, I remember standing on a corner in Stockholm, Sweden, and seeing this thing streaking in the sky above me late at night. That was Sputnik, and that was a good bit earlier than those other American space probes. It's a fascinating, when you are in space, I guess, to see the stars better, to be able to make observations further away. So when the Hubble came up there, you can suddenly see much better than when you had a telescope on the Earth. But really the exciting imagery coming back from space, for many, for myself anyway, is really the imagery of the Earth. Imagery by sensors looking at color, looking at maybe it's radar signals going down and being reflected. Maybe it's LiDAR. Maybe it's microgravity measurements. There's a whole bunch of different sensors that exist. And there are many, many more that can be developed. So taking space and space science as a broad subject matter and looking at what is it that you can put out there in space to be able to understand your Earth better. Those kinds of applications could employ broad swath of peoples and sectors. And then taking the next step, it's not just the observations, it's the analysis of the observations. It is modeling of the data together with other assumptions and so on. And you need supercomputers, you need to have the ability looking at billions of data points of different kinds and putting them together in a reasonable way. And I told you earlier that I'm an oceanographer, a physical oceanographer. And if I draw the comparison between oceanography and the observations that oceanographers do of their environment and space scientists, there's a minuscule number of space scientists in compared to the people who have looked at the oceans either by diving or by having some kind of manned vehicles under the sea. But the big difference is that from space, you see everything. From the oceans, you might have a 50-meter visibility ahead of you. So it's a very different kind of challenge. But being able to collect different kinds of data from different kinds of sensors and synthesize that together with models and good idea through the help of supercomputers to crunch these data, that opens the door for thousands of applications, for thousands of potential jobs. And it takes some funding to seed those areas to grow. So it's not just aerospace engineering. It is engineering, it is science, fundamental mathematics, it's application of computer science, all those fundamentals, and then good language to be able to articulate your results afterwards.
Thank you. Mohammed, my next question is to you. So you spoke about the MURC different initiatives for education. In your point of view, where's the biggest investment that showed the highest impact in all the initiatives that you guys are running? What is the best ways to stimulate students to get into STEM education from your experience?
Honestly, school visits, I would say, is one of the biggest reflection that I get from students whenever I go to any school and give them a speech about space, about satellites, about the fundamentals of our studies. It really attracts students, whether they're in high school, whether they're in universities. Those speeches, I always felt like they're being really inspired by what we're saying. They're really being inspired by what we're doing here in the UAE. And I always get the same question from them. How did you do it? And my answer is simple. I was like, I didn't do it alone. I have the whole, I have a full team with me. So you always have to have this unity when you start something. Of course, you have to do things independently, like your career path. The fundamentals. Maybe I didn't emphasize on that earlier when I said let students just get out of their comfort zone and get into a zone where it would make them feel comfortable in their future. But obviously, I agree the fundamentals are very important. But the students usually in high school and freshman students are really getting interacted into our speeches usually. Another one is, of course, internationally. Whenever for example, the know-how technology transfer that we did in South Korea, a lot of the people, when I tell them the story that I actually lived abroad for around 8 to 9 years to learn something to put my country on the map, on the space map. That's of course, something that means a lot to me when I see Emirati students coming abroad to where I lived for 8 years and experiencing what we did there, because we had students when I lived in Korea visiting us in Korea from different schools, different universities in the country. So I would say universities and high schools, I felt that this is the most, that I would say it really made me feel like they really want to get into space. But the direction how to get there, I always tell them, okay, imagine you live on a highway. Your life is a highway. So there's just one long highway. There's different exits. As long as you come back to the same highway, you'll definitely reach that end point. And make sure that end point is something that, whether it's in space, which is preferably for us, whether it's outside space, there's different ways of coming back, whether it's a personal thing or whether it has to do with your studies. Come back and make sure you reach that target. And that's usually what I always feel comfortable with the students.
Thank you, Mohammed. Professor Morton, what are the key areas to make investments that will show the highest impact?
I think if we had to choose one area of investment right now to have the biggest effect, I would say it's got to be in schools at around about 11 years old. That's being quite specific, but that's the time, at least in the UK, and I'm not so familiar with your education system, where there's a big change between whether a young person is interested in science or not. When they're younger than that, they're always interested in science and they'll lap up everything that you give them. But there comes a time when they start, I think it may be peer pressure, it may be partly the way science is taught in the UK primary schools versus secondary schools, and they lose interest. So we've got to do something about that change and stop students losing interest. And that's the best thing we could do, I think.
Okay, thank you. So I'm going back to Astro Yamazaki. Since we've started working together between Japan and the UAE, we've signed the MOU agreement, we've had a great relationship so far. Do you think there are exciting opportunities with international institutions to come back to the UAE and do something to help develop the STEM education and the sector?
Sure. I'm very pleased to have a very good collaboration between the UAE and Japan. And about 3 weeks ago, Shari, you and some students came to Japan for the capacity building program. So it is it is a great privilege for us to welcome you. And for the future cooperation, we have, of course, many ideas, for the international engagement. And for example, the space programs requires lots of resources, as human resources, and of course the time and the budget as well. But frequent mission opportunities will help for the capacity building as well. So if For example, Japan has an asteroid sample return Hayabusa and Hayabusa 2. It is a Japanese mission, but we have some, sensors and rovers from various countries, and it's an international collaboration as well. So similar way, if we can have, collaboration in each mission, I think it will maximize the benefits among us. So I'd like to seek more collaboration internationally.
Thank you. Professor Anu, the same question, but I'll twist it a little bit. If you were to come here and create a 90-day plan on something to start off, so we're the space agency, what would you start off with to kick the sector with students and get more students interested into education?
So the 90-day plan.
Yes.
I have to say, and I'm not just saying this because we've been invited here, looking at the involvement that that has been really driven by Dr. Alababi and yourself and colleagues at the agency, your plans that we've discussed, that we're putting into place with the support of UK government as a high priority, is pretty much what we need to do. I think the challenge is to maintain it and grow it. So what we have done is focused programs that you are already running for students, international opportunities. You started with undergraduate level students and supporting master's level and higher level students. I think this was the right way. We are continuing with that. We are starting the programs with teachers. We are working with high school students, so that the students that some of you saw during the Congress were a mixture of high school and university undergraduates. So we keep those programs going. I think the challenge is that the students now have an expectation of this, and rightly so, because the focus is growing the UAE space sector to its full potential, developing international partnerships, and there is support across the board. So what you are doing as an implementation plan, as a 90-day plan, is absolutely correct. I think what we need to do, and I think anybody who's been in this sort of large-scale project management cycle will know exactly what we mean, where the projects that start off very well will tend to fail is in the secondary level support structures, the continuation, and making sure that we actually reach that goal that we have set for ourselves.
Thank you. So because we are running out of time, I'm going to allow each speaker to give me their last thoughts. Mohammed, you're okay? We'll skip.
No.
You're okay. Okay. So any last thoughts on education in the space sector?
I think the gentleman here gave enough thoughts, but I would say give it your all. Don't get scared. Face your challenges, and you'll reach where you want. Sorry.
Thank you.
When the Naif 1 is being launched from a site in India, UAE's satellite goes up in a few weeks. On board will be a 1 kilogram nanosatellite designed and built by 7 engineering students at the American University of Sharjah, supervised by professors. There's intense excitement about this going off and the outcome of that one. And that sets the model for the future, what to expect.
Thank you. Dr. Scott.
I would just like to say, first of all, that I'm extraordinarily impressed by what I have seen here in the UAE. And if I had a hat on, I would take my hat off to you all, for what you have achieved is extraordinary. It is simply extraordinary. What you have done is a lesson to many other places in the world. The one thing I would suggest is that we all need to do a better job of connecting all the pieces of space. We cannot simply turn out engineers. We cannot simply turn out lawyers like we saw in the previous panel. Space is big, but the space world is very small. And every space project has policy and legal and cultural and societal and engineering aspects, and they all have to fit together. And we need to do a much better job of teaching our students, our young workforce, how all of these pieces fit together. It's not enough anymore to be a good engineer. You have to understand how the policy, how the legal issues, because let's face it, the policy and legal people always win, no matter what we do. And so I would urge you to build on what you have done by looking for ways to do a better job than most places do in terms of integrating how all the pieces that go together to make up a space center, a space agency, a space project actually fit together so that our young workforce and students can do a better job than we have done.
Thank you. Professor Gabriel?
When I worked with the government of Ontario to develop an innovation strategy, we defined innovation as innovation is about people, their openness to new ways and new thinking to benefit them individually, businesses, and society at large. And therefore, I would like to emphasize what we have heard all day yesterday and today is the most important part for you moving forward is investment in the human capital. And whatever it takes, those are the people, and I'm looking at those good faces here, that is going to deliver on your ambitions. You cannot do it alone, you need them. So please invest.
Thank you. Anu, please.
Yeah, just a simple one, but a cautionary tale. I think what you are doing now is right. We are using the Hope mission to Mars as a hook, but then we are looking at the satellite applications industry that's already been established here, that of course is the revenue generator massively, and we see this on a global scale. But I think we have a cautionary tale because we're seeing a trend in the UK that I'm worried about. There are some people in the United Kingdom, I think this has happened in the United States as well, who are saying that actually when you look at the business case for space, the revenue generation, it's all in satellite applications, data applications, utilization. What's the need of having an exploration agenda, a fundamental research agenda as well? And what I would say is from my experience in the sector, working with people, what we call upstream, downstream, in exploration, in applications, many of those people who are at the cutting edge of satellite applications that seem to be so distant from space exploration ideas, what drew them into the sector originally was this wonder and joy and awe of space exploration, where they developed many of their fundamental tools that they are using intellectually and in terms of their skills, was in the exploration agenda as well. So what I would say is that we cannot have future space exploitation without continued space exploration as well.
Clear. Thank you. Professor Morton?
I could have said many of the things that have already been said, so I'm slightly jealous of them having the opportunity. But if I have to say one thing that's different, we've heard a lot about students and engagement with students and how good they are. And I've been so impressed by the students I've met in the last couple of days. But what we haven't heard very much about is teachers. And of course, without investment in teachers, you don't get those bright, engaged students. So my advice would be, as the last word, let's make sure we invest in our teachers, stimulate the teachers, because a teacher teaches 1,000 students, and that's how you generate the human capital.
Thank you. Dr.
Yeah, I find myself in a similar position, but I guess maybe picking up a theme a few of my colleagues have brought up, but really focusing it maybe a little. My major message would be to the students. I mean, and it's a little bit, I think, preaching to the choir, because obviously the students who are here are already heavily invested and drawn to space sciences. But I think the advice we heard earlier is apt. You know, don't be afraid. This is a big space. But the opportunities you have here, the resources that you have here are phenomenal. I mean, you know, I've had this experience in my 7 years in the UAE many times of witnessing events like this, participating in them, hosting events at our campus. You know, in 7 years at Khalifa University, just to give one example, we've had more Nobel Prize winners give talks to small groups of students than I can remember in 18 years at Duke. And Duke is a pretty prestigious place. So I think, you know, the level of opportunity that students have through the governmental agencies that have been established, through our universities, is really phenomenal. And a lot of the socioeconomic barriers that exist elsewhere in the world for people to have access to really high quality higher education and the education that comes before that as well, a lot of those barriers are not in the UAE to the extent they are other places. So my message would be to the students is that your opportunities in this space are almost unlimited, except by maybe your own hesitancy to go out and engage it, because the people are here. Our partners are here. They're here regularly. And there's a lot to learn from them. And I would really encourage you to engage it. And again, I know I'm preaching to the choir, but tell your friends as well.
Thank you. Yamazaki?
Yes, according to my experiences through the training and the mission in an international program, I felt the spirit of space is very similar to the Olympic spirit, which is to build a peaceful and better world with a spirit of friendship, solidarity, and a fair play, and to inspire and motivate the youth of the world to make their best through education and the challenges. And one more thing is to, once we go outside of the Earth, then we can learn more about the Earth. So I think the space education is not only learning about space, but it is learning about our home planet, the Earth, and also learning about ourselves through this space spirit. So I appreciate this opportunity, and I'm looking forward to working together.
Thank you very much. Thank you, everyone, for staying with us for a long time. I would like to thank my speakers, this panelist, my very esteemed panelists. I'm very happy and honored to have you with us today. And thank you for being part of the inaugural edition of the Space Congress. It is a very special event for us, and you've been very special guests, and your input has been very useful for us to learn from.
Thank you.
So thank you very much, everyone, and this concludes the session. Thank you.